A very good morning to everyone present here. We are delighted to welcome you all to our 12th session of UNI's International Faculty Development Program on Data Science Tools, organized by the Department of Artificial Intelligence and Data Science of Ishwar Engineering College. Today's session is on auto It is an honor for me to introduce and welcome the keynote speaker of the day to our session, Dr. Shobna Gracia Chandra. She is a faculty in the Department of Computer Engineering at University of Technology and Applied Science, Kannada. Her field of specialization are computer science and engineering, database system, data mining, and data science and machine learning. She received several honors and awards like Young Women in Engineering Award, Young Scientist Research Grant, House Perfect Award, Data Receiver Award. She made over 71 contributions and participated in several international conferences. We are happy to have you with us today. The session is yours.
Thank you very much, Ms. Sabita, if I'm not wrong. Thank you very much for the introduction. And a very good morning to the HOD, the committee members. And I thank you for giving me this opportunity to be a part of this FDP. And I thank Dr. Nirmala who invited me to this FDP, and it was nice to work with her because I missed the opportunity before this. And yes, we will proceed with the session now. So today I'm going to, yes, dear, it's not audible?
It's audible, ma'am.
No, somebody has messaged that it is not audible, sir. I think Mr. Ramesh.
I think previous introduction session.
Okay, fine. All right. Okay. Thank you, sir. So today's session, I'm going to talk about AutoML, as you all know. So AutoML is the latest in machine learning. So because I just didn't want to jump into the tool, I thought I'll just give a brief introduction. I will not take much of your time, and then we will move over to the hands-on session. So if you're able to, if the participants are allowed to speak or give the messages, if you can just tell me your ideas about what you are right now doing in machine learning. I understand that you have already had a session on a lot of data science tools. So basically today's session, I'm going to just give the introduction about the data, the machine and the learning, and we'll move on to how it is automated. So generally, when we say artificial intelligence, we think of it as a technique. Actually, it is only the final end product. So we are all naturally intelligent, and we try to make the machines artificially intelligent. So everything that goes into making our computers, machines, televisions, smartphones, everything making it smarter is data mining, machine learning, and so on. So generally, when you say data mining or smart systems, IoT, big ML, auto ML, whatever it may be, for everything you need the basic content that is data. So without data, even us, as we become doctorates and masters because of studying, okay, and we need data to study. Only when we have data to learn, we can reproduce what we have learned in different ways. So that is the basis for building our brain's capacity or learning or knowledge capacity. Similarly, to make our computers intelligent, they need to be fed with good data. So when you come across some data, you need to ask yourself the question whether the data is authentic, whether it is correct. Because if you're going to learn the wrong outcomes for the exam, you are not going to get a good score. You have to learn what is in the syllabus for you to reproduce your answers and get a good score. Same way it is for the computer. If you're trying to train the computer to do a particular job, you're supposed to ensure that what you're feeding to the computer is the right data. So is it authentic? Is it complete? Are there missing values? Is it linked properly? Are there good relationships in it which can give you some knowledge or give the computer some knowledge? These are the things you need to first ask. Without this data, there is nothing smart in the world, including ourselves. So once you say about the data, once it is ready, it is complete. And one more thing, data is a dynamic process. The data is never static, like COVID or like any medical data, academic data. Our scores, our sicknesses, our way of recovering, the medicines, everything keeps changing over time. So how is it possible to answer that question, whether our data is complete? So it is with reference to time. So at that point in time, the data that we are having, is it perfect for the study, at least for the study, at least for developing the model. So everything goes with what is our final objective, what is the input we are having, and what is the processing we are focusing on. So finally, if you see, all this machine learning comes to the basic architecture of a computer, the input, the output, and the CPU. So the data is where the input comes in. The output is how smart your system is. And the processing is all this machine learning, auto ML, and the different tools that you are using. So when you come to data, there are different types. You might already be aware of this. You have data which is complete with all the labels. There is unlabeled data about which you have no idea what it is actually referring to. You just put the data together based on how they look similar to you. So again, there is a lot of discrepancies here. For one person, the data may look similar in size. Another person may be interested in its other characteristics like color or cost or the time taken to acquire the data or how many dimensions the data is covering. So again, everything in machine learning depends on the scientist who wants to get something out of the data. What is his perspective, his view? So when it comes to research, nobody can say that one person is a good researcher. His view may be different. So it is interesting to other people. Your view may be limited, but that doesn't mean it is not good. In your own view, if you are able to find something that is novel in the data, it is very good. It is the perspective with which we see the data and how we use the data to find something new. Everybody cannot find something new. All of us are not Newtons or, to find something that is that alarms the world. But in our own way, if you're able to find something that adds value to the other researchers who are doing the work, then it is definitely good. So in today's session, I'm going to talk about something like that, where you have this normal machine learning, which we do. You can see here, you have the input, you get the good features, you classify, and you get the output. So this comes under what is called general classification. So this is called what type of classification? Is it binary or multi-class? Have you come across those words? So binary is where you have yes or no. That is the only thing you can find out. Whereas in multi-class, you can find out, for example, you have different types of cancers. You can find out and allocate according to the feature of the person or the symptoms of the person or the medicines he's taking, which type of cancer it is. When you have many classes, a yes and no is called a binary classification. So what is the difference between this machine learning and deep learning? So in my experience with the deep learning and traditional learning algorithms, the data I have worked on, deep learning does not give very good results. And I find it very difficult and boring to code with deep learning. It does give results in certain cases like images. For images, convolution neural networks, deep neural networks, artificial neural networks, they've all given slightly higher output. But the time that it takes to learn that coding, to learn those tools and to correct the errors, I prefer to go with conventional learning algorithms. I don't have many publications where deep learning algorithms have given good results. So now coming to machine learning, that is the processing. And now we have what is called data mining. So how do we link both? Both are actually, in my terminology, you can actually just use them interchangeably. Because without data, you cannot do machine learning. And without machine learning, our data is useless. Okay, so again, here we have to prepare our data to make sure they are complete. You get the good features. Then you find out whether it is yes or no, or the different classes. Clustering and association rule mining. There are AutoML tools even for these two, but it is not yet authenticated to be used in journals. So I'm not going to go into that now, but those phases are still there. And for those who are still not clear about what is the difference between classification and regression. So as I showed here in this example, classify is when you have very standard classes to put the data into. For example, when you have a student, you can put him as pass or fail, or you can grade him as grade A, grade B, grade C. It is well defined. They have well-defined boundaries. But sometimes when you want to classify them based on their scores, their percentage, you cannot exactly say a student will score exactly 90 or exactly 80. He may score 89.99. He may score 90.01. So when you cannot classify them, but you have to give a range of continuous values to classify those kind of students, it is called regression. It can be, a score is just an example. It can be even our temperature, our climate. Okay, you cannot define the temperature as it's going to be exactly 40 degrees C. It may be 40.12. So when you are not able to define boundaries for your classes, you just call it regression. The ultimate process is the same. It is only the output which is different. But in research, when you write papers, we are supposed to be extremely clear about what is classification and regression. We cannot use those terms interchangeably. And clustering, all of us know, forming groups when you don't know what that group actually tells. You don't have a name for the group. So here, I don't know what are the names for these three different types of balls. Maybe this, you call it a football. Maybe this is a baseball. I don't know what about this ball. So maybe you can take it as a semi-labeled data. So how do you actually put it into classes? By their features. You know, this has just a black and white color. This has just a black and red, and this is not at all white. So just based on the color, you can put them into three groups. And this is how your calculation or processing is going to see the data. So this is the basics of what we are going to do today in AutoML. So what is this auto? Auto is where we are going to automate all these processes. So as I told you, the only thing that we have to check in AutoML is the data, because that the computer cannot do. So we have to make sure that the data that we are giving to the AutoML software is complete. Like this, it has a good definition of features. What it is going to do here, what this model, you cannot even choose the model. Okay, so I assume you all know what is a model. A model is any algorithm. It may be a decision tree, it may be a support vector machine, it may be a neural network, a Bayesian classifier. So I have not gone into the depths of those, because first thing, you already must be having an idea about their working. The second thing is, in AutoML, even if you know about the algorithms, it's not going to make a big difference, because you are not going to do anything. It is all automated. The only thing you need to concern yourself with is how the data is going to go into the system, how good your data is, how complete it is. If you understand the data, everything else is taken care of by the software. So when you say about the data, so now I was talking about the data, all these things you have to understand. So how big is your data? What is the type of your data? Like I told, is it percentage or is it well-defined grades? Can you classify it like that? Is it having only numbers? Is it having binary type of data, yes or no, male, female, true or false? Or is it having numbers? Is it very different, like decimal numbers, or can you keep it as whole numbers? All these things you have to first analyze, because there are some AutoML algorithms which do not work on all types of data. That you have to work it out and only find out. You know, there is, because each software is getting updated. The software which I'm going to go into today does not work with images, but there is a business teams plan which allows you to classify images as well. So each software is getting updated. So if a software today is not working on alphabetic data, maybe tomorrow it will work on that. So that is something that we have to learn by practice. Storage restrictions is again, there are certain software, open source software, which do not allow access, sharing access. So they are commercial. It is only for that particular person, for academia purposes. You're not supposed to use it for in your institute across people. And if you're using servers, some software do not allow you access. So those things you have to be careful before you delve into a particular software. It is all these software are normally patented. So if we are going to have any kind of violation, it may lead to legal problems later. The third type is serial and parallel algorithms. Still, AutoML has not come in serial and parallel, though today I will show you how it is working in parallel as well. But we don't have to concern ourselves with those things when it comes to AutoML. This is the general questions that we need to answer about data when we are doing any type of conventional or deep machine learning algorithms. So why I'm telling you all this is AutoML is so easy. You don't have to actually worry about anything. You only have to be worried about the data, whether it is ready, complete, correct, with no missing values, and so on. So these are all the programming platforms, some of which you might have seen in the last few days. And I think, some of it might have been coding, some might have been GUI. All right, I find it very difficult, to take this TensorFlow, installing the packages, and my system becomes very slow. So I have a lot of problems working with all those software. And this software, which I'm going to show you today, it was very easy for me to work on it. But the problem is it is very expensive and commercialized. But you do have a 14-day researcher license, which comes free of cost. And for those who are just becoming into research, students who want to publish some good papers, that 14 days is more than enough for you to have take a data, run it on the software, and get an idea of how AutoML actually works. Okay, and maybe as an institute, or if you're in some funded project, you can definitely go ahead and buy this. So these are all the general characteristics of programming platforms, and this is the automated. If you see, there is not much of a difference, only that all these things, this hypothesizing features, finding out features, computing them, or creating new features, whatever it may be, everything is automated. So here, if you see, we don't have anything. We don't have to do anything. It is all automated. Okay, it is all visible. So it makes your work very easy. The problem here is, you may ask, then what do I learn from this? The problem is you should not come into this and learn. You should already have an idea about machine learning features, work with conventional machine learning, work with deep learning. Then you come to AutoML. That's when you realize how powerful it is and how much of work it is doing. And only when you have that basis of theory in machine learning and data mining, you will be able to write good papers, because that's when you will know how much of work is automated in this AutoML process. So I would first like to stop here and ask the audience if my speed and voice is clear to them. Is it all right? You can just raise your hands, or just show me some.
Yes, ma'am.
It's
Going
fine. Okay, thank you. Yeah, thank you. All right, so these are some of the AutoML tools. I think AutoML, most of you might have heard about H2O, which is very widely used. But again, H2O, the downloading and installation part, it took time for me. I didn't have time to do it. And Google and Teapot, some of them are commercialized. So I generally, like to go in for something which helps me to visualize, graphical. Okay, data visualization is yet another research topic. Though I am a computer science person, coding, I find it a little boring, because it's just, even in TensorFlow and Keras, what do you actually do? You keep installing all packages and you keep calling the libraries which are already there. I actually think I don't learn much from those, because it is already there, and you just change the Adam function to ReLU function, and you just try to change those data and see whether your accuracy changes. So that's why I try to go into something which is visually appealing to me. So these are all the set of tools, all that you learned, 9, sklearn, all these are also auto versions are available. Vega, Auto Vega is available. And today I'll try to show you, if time permits, what is the difference between the tool I'm going to show you and what the auto ones do. So these are self-explanatory, the slide. So some of them have a lot of cons. AutoScaleLearn works only on Linux machine at the moment. It may come to Windows and Mac later. And Teapot, okay, it is a tree-based pipeline optimization tool. The name itself, is very repulsive to me. Tree-based pipeline optimization tool. I really don't understand what it means. Anyway, it doesn't process alphabetical string values, so I didn't go into it at all. So H2O is widely used as of now, and Cloud and even Transmograph AI, AutoKeras, you can see what are their disadvantages. All right. Yeah. So with this, actually, my theory part is over. So I'm now going to move into how you are going to download the tool and do it. I didn't even name the tool so far. I wanted it to be interesting. All right. So all of you can just move with me to Google. It is accessible to all. Okay. And yeah, so the name of this tool is JADBio. All right. It stands for JADBio Automated Machine Learning Platform. So JAD stands for Just Add Data. Okay, just add data. It is actually meant for mostly biological data sets, but you are able to work on other data sets as well. So as I said, this will be useful for those who want to take up some data and try to find out how AutoML really works in it. So you just go to this JADBio AutoML. You can do it right along with me. If I'm going very fast, please stop me here. All right. So if you're using it for the first time, you need to sign up here. Or if you just want to see how I'm using it today, it is fine. You can sign up later and then you can log in and do. So I already had one with my name, okay, but it has expired. So today I'm going to use Dr. Nirmala's login. I just hope it works. Yes, so this is how the tool looks like, okay? You can go through all the help if you want, but actually it is exactly not necessary. So, you know, when I look at it, it looks really good. So I like things which look like this. It's easy to work on. So as of now, there will already be use cases here. You can go through those use cases. And always you start with projects, because if you put your data in one project, you can have a lot of data sets. So it will be easy for you to categorize them and get back to it whenever you need. So is everybody following up with me? Do you need to give me time? Anybody ready, willing to sign up now, or will you just view it on the screen? Shall I proceed? The participants? All right, fine, thank you. So when you take up these projects, all right, so already I'm having a project called FTP1. So we'll start with creating a new project. So when you start with creating a new project, so just give a name. So I already have one called FTP. I'll just give one as FTP2. Here, if you want, you can give a description of your project, because as you start creating many projects, it will, you may get confused where you stored your data, because the problem I normally face is after I finish my work on a paper and I submit it to the journals, you know, some journals take close to 2 to 3 months. Then when they give back their comments, I actually forgot what work I did on that paper. And I have to go back and see what were the results, what features I used and things like that. That takes a lot of time. So if you give some description about the data, it is well and good. So now this comes to just add data, which stands for JADBio. So you have all the features here. Just go here to this add data and you have this upload a file. Now uploading a file, this works very well with CSV files. Okay. So I already have a well-defined CSV file here. I have already worked on autism-based projects, but today for you, I will also show you on the screen how to start with getting the data. Okay, just a second. Yeah. So I'm sure all of you will be knowing about Kaggle and UCIML data repository. So most of you might have worked with data sets from here. So I will take a real-time data set. Normally, when you are doing research for the first time, please avoid, in my experience, I normally avoid the old data sets because already a lot of work has been done on it. Okay, so you might just be able to add to the existing knowledge. So normally I take in data sets which are in the latest category. And now because I have to show you the results online, I'll take up a data set which is comparatively smaller in size, so the results will be fast. Actually, JADBio doesn't have a problem with big data because you can use a number of cores. But for the sake of easiness, I'm going in for this data set. Okay, if you want, I will show you the output with a big data set as well. So this maternal risk data, you can see there are just 7 attributes, so it should be small. When you are coming to see a data like this, please don't skip this data set description. That is very important, okay, because that you need to write your papers. Just taking some data and giving the results doesn't make sense. So here it is in CSV format, so it is good. So I'm just clicking and downloading it. So now it is in the downloads folder. You need to have a look at how the data is, because when you go into the JAD data set, it will ask you some questions about the data. All right. So yeah, it is fine. All are numbers. You have some decimal numbers here, and it is a multi-class classifier. All right, you are having mid-risk, low risk, high risk, and so on. So we will see how JADBio works with this. So yes, now my file is ready and I'm going to upload it. So add data, upload the file, browse, and yes, the data is right here. So you need to check whether the data statistics that it is mentioning is right. Okay, so then you go to next. Now here, this is why I told you need to know how the data set already is. The files, whether they include the feature names. Yes, the feature names are included in the file. If you don't click this, it will take this age as one of the attributes or as one of the values, and it will not process your data set. So when you say files include feature names, the feature names correctly go up to the files. And do you have sample names in your data set? No. Okay, the data exactly starts with the values. So if you click this without knowing about your data, now this value will become a sample name. So these are simple things which we generally miss, all right? So the file has samples in columns, not rows. Suppose your data is inverse, no? Like you're having, I came across some data sets which had the values in the form of columns. You can easily transform it using JADBio tool. You don't have to do it manually. That also JADBio does it automatically. So now my data is ready. If you want, you can just check if all the rows are fine. Yes, up and all the samples. So here itself, you will know how many samples are there in your data set. So the statistics that you need is available. It can be verified. So now you're creating a data set. You give it a name which you understand. Okay, maternal health. Right, and if you want, you can give a description. Otherwise, you can just leave it. Okay. So now your data set is created. If you are writing a paper only on data analysis and visualization of data or how to get the statistical features of data, JADBio offers you a lot of graphical based representation for that. Okay, about each and every attribute, what is its role, what is the range of its values, how it varies across the different instances, everything is visible. Now, body temperature, if you can see, for maximum number of samples, it is at a very high level. Whereas if you see this age, okay, it is so highly varied. Of course, you know, the reproductive age of women is across a big range. So obviously it will be varied. So you're able to get a lot of information if you want to do just data analysis or statistical analysis of your data. Fine. So now I'm having my project and I'm having my data. You can just skip this if you're not doing anything with the data. All right. So now your data is here. Now, what if you want to transform your data? Okay. So what is the meaning of transformation is if you see this data set, if you see this particular data set, there is no attribute which is not important. For example, if I had an attribute here, which told me the patient name, okay? Seriously, I don't want this patient name to be involved in the classification. So if you want, you can just remove this sample. If you want, that can be done in transformation. Or if you find that some particular feature, you know, you don't want it to be there for the class. It is important, but for your classification, you are only focused on some other features, then you can remove. So removing feature is the simplest transformation that I have done. All right. There are other transformations like replacing missing values. There are no missing values in our data. So you can find the mean of the other values and replace it, or the median of the other values and replace it. Like this, other transformations are also available in JADBio, but I have not done them. If you come, I didn't need to. Okay, my data set did not have missing values. So if you need to do, you can do those things with transform data. Okay, you can remove features or retain only those rows which satisfy a certain condition. Suppose this data set is focusing only on women who are above the age of 40, who are coming for maternal health checkup. It is not worried about the women less than 40 or less than 35. Then you can remove those rows. Okay, if you want to. You don't have to do it manually in the Excel sheet. Automatically, this will do it for you. JADBio. Right. And if you're having multiple data sets and you want to merge them, all those things can be done here. All right. So it is up to you to take data sets, merge them, and find out how it works with JADBio. Okay. Right. And changing the type of selected features is, suppose you're having the gender of the person. Okay. In this case, all will be females. But suppose you're taking up for some other disease or students, you want to classify based on the gender, males and females. Classify based on the gender, males and females. If it is 0 and 1, okay, it is difficult for you to identify or remember which is male and which is female. So you can easily change it to M and F, okay, or boy and girl. It's easier that way. All this JADBio will do for you. Right, so here right now we don't need to do any transformation, so I'm not doing it here. So go here to this analyze data. There is a disturbance. Is it okay?
அது ஃபோர்த் யூனிட் தானே, ஃபிஃப்த் யூனிட் படிக்கவே மாட்டாங்கல்ல. புரியுதா? ஃபோர்த் யூனிட் வரைக்கும் வந்து நம்மளே புக் எடுத்து கூட படிக்க வச்சுக்கலாம். படிக்கவே மாட்டேன், அதுக்காக எழுத
சார். Is it okay, sir? Is it fine? Can I proceed?
Yes, ma'am. Yes, ma'am. You
Yeah,
can proceed.
thank you. Yeah. So now we have added the data. We did not require transformation. I'll show you an example where we need transformation, and then we will go in for now the analysis. Okay. So when you're coming here to this analysis of data, this is the only data set that right now I have stored. So it says the data set looks fine. So you move. You know, the first time I was trying to load the data, there was some problem with the attributes. It was not accepting me to load, accepting my data set. So anyhow, yeah, as I said, that comes with practice. Okay. So here you have a lot of features. So here it clearly tells you, you can do classification, regression analysis, or even, you know, like a prediction. The survival analysis was useful for us when we tried to find out whether people with certain cancers in a certain stage of cancer, how long would their survival be? What is the rate of their recovery? So for those things, this survival analysis was useful. But right now we are going into classification. So we have to choose which is our class. So it is the risk level. Okay, so it is going to check whether the risk level is fine. So it says yes. It is easy to, it itself will tell you because it is well defined. No, it is a category. It is a well defined category with a well defined boundary. So it will say we are going to perform classification. So now in this analysis options, you have a choice. As I told you, feature selection also is done by the AutoML model. Okay, you don't have to actually do it. But do you want to do feature selection? Is it important? Now see here in my data set, actually I have very few features. So if I don't want to choose features, I will just leave it like that. I want all the features. Consider only interpretable models. What is the meaning of this? There are two types of models in machine learning. One is a black box, the other is a white box. Okay. When you take up the tree-based classification, the decision tree, it is interpretable. You can see the tree. You can see, okay, this particular feature, if the value is less, then it goes to no or high risk. You can see the tree and understand something. But when you take deep learning and neurons, I don't understand anything. Okay. I really don't understand how the Adam function works or the ReLU function works. All I see is the accuracy. And that really irritates me. Okay. At times. So when you consider this at the end of the day for our papers, if we get a good accuracy, that is enough. So that's a different story. But when you're trying to learn something and the importance of a feature and how it contributes, considering only interpretable models for the first instance is good. All right. But anyhow, we will try all the different features. So as of now, I'm having an annotation request. Is that fine? It will not affect the meeting in any way, right? All right. All right. So what happens is now I'm going to not include anything. I'm just not having only relevant features or only interpretable. I'm giving JADBio the full freedom to do what it thinks is best. Now configuring the model tuning effort and resource usage. So here you have three types. The preliminary is what I have worked on because typical and extensive actually take a lot of time, but maybe because on my data sets, which were big, so maybe on this, the typical and extensive may take less time. I'll do one thing. First, I will show you with preliminary. Maybe the next run which I give, I will do it with the typical. Just give me a break. My laptop is going out of charge. I will just charge it. Just a minute. Yeah, sorry about it. So here, when you're, say for this particular data set itself, the number of CPU cores. Now, this is what I meant. So here, this number of CPU cores, you can change it even to 2. Okay. Can I just, yeah. You can change it to 2 or 3 depending upon the size of your data. If your data is very large, if you use 2 or 3 cores, it will be very fast. Okay. So that is about this one. Actually, for this data, we don't need, but you can do it. That's what I'm trying to show. Please go to this advanced options. So identifier feature is if you're having any one particular feature, which is very good, which shows how people are grouped. For example, like I told you, when you're trying to find the gender-based performance of students and you want to distinguish between the boys and the girls, here you can give the gender as an identifier feature. I don't have anything like that for my data. The metric by default is area under ROC curve. So generally we go in for accuracy, but in medical data sets on which I have worked on, we actually go in for Matthews correlation. So what is this Matthews correlation? If you people have come across it, is fine. If not, Matthews correlation is when, when we come across medical data sets, we cannot always say that everybody will have or will not have the disease. For example, if you take during COVID, the data sets we got during the Omicron phase was out of say 5,000 samples, 4,800 samples had COVID. We had only 200 samples without COVID. So how is the data enough to teach my computer? It is fully focusing only on the COVID people. It is not able to find out those who are not having COVID based on the symptoms or their age or fever or whatever. So when your data set is so unbalanced, okay, the computer is not having sufficient data to learn. If you don't provide enough teaching material to your students on all the outcomes, how will they learn? So it is just like that to the computer. So Matthews correlation will correctly identify whether your model, that is your decision tree or Bayesian classifier, whichever model you are building, is correctly able to distinguish between both the classes. However, whatever type of data you are giving, okay? So I always go in for Matthews correlation. You can choose anything because it will anyhow give all the metrics. Okay, that is what I like with the JAD Bio. Now this maximum signature size means the number of features. For example, in my data sets, I have close to sometimes even 3,000 features. Okay, if I want only the top 25, you can give that number here. Or you want the top 100, you give that number here. Here we are having only 7 features and I'm not even using feature selection. So it doesn't make a difference. So plots, you can have any type of plots. I'm giving for all the plots. I will show you how all the plots look like. Okay, so now everything is done. I'm giving the full freedom to JADBio, only the metrics I'm choosing. All right. So when you run the analysis, so you can see the time at which it is running here. It's pretty fast. All right. For me, for my data set, sometimes it takes 10 to 15 minutes. So while it is running, if you people, I wanted to show you the difference with AutoVika also. So if you have already Vika installed, I will show you how to install AutoVika. I'm not sure if Vika has been completed in the sessions for you. Have you completed Vika already, sir?
Ma'am.
Vika's over, sir? Vika?
Yes, ma'am. Yes, ma'am.
Okay.
Vika over.
Okay. Have they taught about AutoVika also when they did Vika?
No.
No. Okay. So all of them will be having Vika in their systems. Okay. Then I think we can download Vika as well. Let me see if it's over. It's getting over. So if you're having Vika, so while this is taking a little time to run, so this is the Vika tool. If you have it in this, how you actually install this AutoVika. As of now, I have already installed it here. Here in this tools, okay, you have to go to this tools, go to this package manager. And here actually I have already installed AutoVika, so it is not visible. You will have AutoVika here in this Ace. So you have to choose that AutoVika and click install. So it will automatically install AutoVika in your original Vika tool. Okay. So now this is done. So we will go back to this analysis. So here again, you have 3 types of actions. One is viewing the results, applying the model, and renaming the analysis. What is this applying model? I will tell you. First, we will come to view the results. Okay. So when you're coming to view the results here, now can you see here? though I gave no feature selection, it has done aggressive feature selection. It has done normal feature selection. It has done interpretable models. It has also done the normal best performing model without interpretation. So that's what I liked about this tool. Okay. So when you give it the full freedom, it gives you all the information in just one shot. So here the feature right now we are here in performance. It has selected all the features. It has told you which algorithm, how many trees, what is the leaf size, what are the variables. All the information you need to write a paper is available here. It gives you the curves, okay? It gives you the average Matthews correlation coefficient, accuracy, balanced accuracy, precision, MCC, positive rate, sensitivity, specificity. You name the metric and it has the values for you. All right. So this is the values for this particular data set without any feature selection with full features. So here, even if you click feature selection, it is only going to tell you JADBio selected all features in the original data set. You can download the features. So when you download the CSV, so it has selected all the 5 features, okay, which are available in your original data set. It has selected the signature. You can, if you are selecting a few features from say 3000 features, only those features will be listed. So here there are no values of how those features performed. It is only the list of features because we didn't ask JADBio to calculate the values. All right. So come here to this interpretable models. Okay. You can see some difference here. In this normal performances among all the models, black box as well as white box approach with different values of the leaf size and variables, because it is a random forest, it has given the best value for accuracy. Okay, you can remember it. The average is 0.72. So when you come to the interpretable model, it is using only a decision tree. It is not using a random forest. So the entire model, it has changed. And accordingly, the parameters for that particular model has changed. But this is also using all the features. Okay, this is also using all the features. And here, if you see, you can see the accuracy is slightly enhanced to 0.763. So it was 720 and the average Matthews correlation coefficient is reduced. Now come to the feature selection. Okay. So here, though we never asked it, it has already applied an automated feature selection. And again here with feature selection, it goes back to the previous model. Okay. With 100 trees. So here, if you see, can you see the accuracy is again 78. It is slightly higher. When you come to aggressive feature selection, now what is the difference? I think this term aggressive, I visualized it for the first time in JADBio. I'm not sure about you all. So generally when we say feature selection, no, it keeps comparing with the accuracy. So it will keep reducing the features or it will keep adding the features till the accuracy reaches to a certain level, beyond which it does not increase. That is the work of feature selection. What this aggressive feature selection does is it forgets about the accuracy. It only sees, okay, instead of focusing on accuracy, it sees the difference in the values of the features. For example, here if you see the body temperature, it is 100, 98, 101. It is 98 for most of the people. Okay, so it is 98 for most of the people. And if you see 98, most of them are in low risk. So it does not focus on the accuracy. It focuses on the features which are able to give a lot of information about the class. That is all. Even if they may give less accuracy, it is not bothered. But our reviewers don't want it like that. But anyhow, I have a paper on aggressive feature selection as well. It does give less accuracy most of the time, but the features that it shows have very good contributing factor. So then reviewers ask, then why does it give less accuracy? If the feature that it is showing is able to tell the class very well, why does it give less accuracy? It all depends on the data. Maybe my data is not good. I need more samples or I need more features. Okay. So that I cannot do anything. What data I'm having, only with that I can work. But these are different things we find out from the features, from the data, from machine learning, that accuracy is not the final judge for any model. Okay, there are many other things that we have to study if we have to come across a perfect model which will make a final smart solution. Right. So now you will ask, what is this no feature selection? So see here, it is the same as the best model for performance. So because here in performance, we already have the full selector, but it just shows you that they are similar. Okay. So you don't have any doubts about your results. So now how do you write it as a data set? What are the different things you can visualize here? You have something called the analysis report. Okay. So in the analysis report, it shows you how the learning process MCC is varying. It is showing MCC because I chose MCC. If you choose accuracy, it will show you accuracy. So it shows you the graph as you keep adding or the learning progress during each time, how the accuracy was improving and reducing, and when it reached the final stable stage. So all this normally we have to do when we use Vigo or other tools. Here JADBio is doing. It shows you what is the testing method it used, repeated tenfold and 20 iterations. Okay, so it will be perfect. More than 250 algorithms were trained. So we cannot do this. Humanly, it is not possible. Okay, just comparing 5 algorithms takes a lot of our time. It has compared 250 algorithms, used 2 cores. What is the time? All right. And it gives you the entire time taken. What are the parameters? And it shows you the performance. So 30% in the sense, very less accuracy. So when it says 0, it is completely less. Okay, it should be somewhere close to 70s. So this is the highest accuracy that we got, our highest MCC, I'm sorry, whatever measure you use. All right. So if you want, you can even have it as a PDF file. Okay, if you download the report, it will come as a PDF file. If you download predictions, it will come as a PDF file. So this is what you need to do your paper on AutoML. But the problem here is, when you are doing your paper, they will tell it is already an existing work. So it is obvious AutoML is automating. So how can you add something new to it? When the software is automating a process, it is not possible for you to add something new. So you have to write your papers in such a way that the person understands what work you're actually doing. See, our job is, as far as PhD is concerned, our job is to do something new. All right, to add something new. But when you're finally in the market, in technology, in projects, funded projects, they are not bothered whether you're doing something new. What they want is a final output. They want a final system which is intelligent enough to work without any errors. And AutoML is one of the best models I have seen, which surpasses human capacity to compare multiple models, also give you the good features, also try out with number of cores. See, in India, we don't have the funds to buy high-end systems within our self-financing colleges. So it is providing you CPU cores. Okay, so this 14 days free. After this also, you have the basic model. Okay, the basic researcher's plan is free. And you can do all this in the basic researcher's plan also, but maximum you can have only 3 projects. But you can try up to 10 data sets in it. All right, so you have a lot of options here with JADBio. You just have to use it. So what is not available is, see, when you come here to this analysis report, I go back to the original, you have this visualization. Okay, see, this visualization clearly shows you 2 types of plots and the different classes. Can you see it is very difficult to actually segregate the classes based on this data? They are also intermingled. They are also close. There is no clean boundary. That is why the MCC is very less. So you can display it as 2 types of plots. One is based on the UMAP. It is a uniform dimensionality reduction map. All right. So PCA is the normal ones that we use, which take 2 principal components. That also is not able to show with 2 principal components. Maybe if you take up 3 planes, it may give a better result. You can download these as images. You can download them as CSV. It will give you the values. Okay. And here, if you want to see how the class high risk compares to the other classes, the predicted probability based on the probability density function. So if you have studied the classifiers, this is focused on the Bayesian way of classification. It takes the probability from your features on how well a particular feature or the entire set of features focuses towards a particular class. Okay, so you can see that it is towards this 1. All right, based on the probability towards 1 goes for high risks. So suppose you change it to low risk. Okay, so low risk is stopping here. When you say mid risk, again, the values are ranging here with the probability density function. So you need to study more on the theory of all these algorithms to put it in the form of papers. This tool helps you to process and classify your data, get all the necessary metrics, and identify good feature signatures. So now with this feature, we could not get, we did get okay, let me show you the feature signature. Yeah. So in feature selection, earlier it says it selected all the features. Here it is selecting only 5 out of 6 features. Okay, so these are the highest features it has selected. You can download this as CSV. So here, if you see, it is showing you the feature importance. So when you're using only, this is BS. Okay, so we have to learn from the repository what is BS. Yeah, blood glucose levels. Okay, so it says the blood glucose levels is one of the finest indicators. So when you're using only it, okay, you're able to, the performance drop is around 10%. Then when you're including heart rate, see the big difference. So from blood glucose to heart rate, when you include the features, there is an improvement in the performance to this extent. And then it's slowly, so this is the amount of error. Okay, so this is the best. So beyond this, even if you're adding, I think the age, it doesn't make much of a difference. Okay, so all these things are very useful when you want to put them in the form of papers. Okay. So here it tells about the percentage performance drop. Here it tells about how much it improves. Okay, so this is the performance which is achievable. So this is basically with how you take the data set and you run the different algorithms. Is it clear so far? Is it clear? Shall I proceed?
Yes, ma'am.
Okay. So next, I told you I will tell what is about this applying the model. Okay. So this applying the model is you've already had a comparison of different algorithms on the data set. Suppose you have a test data, okay, and you want to validate your data set or whatever model you have found out against the test data. Again, you have a choice here. You want to choose the one with the highest accuracy or one which is interpretable with feature selection, without feature selection. It is your wish. So I go in for one with feature selection here. I'm choosing my features. Only 5 features were selected. No, so see, automatically it will show the 5 features. In Vega, you may have to select the 5 features at times, or sometimes when a lot of feature selections you are using, Vega doesn't remember them. So here, whichever model you choose, automatically JADBio will remember what are the feature signatures for that model. Then you move over to next. So you want to validate them against your training set or against your test set. Unlabeled is test set. Or like, you want to enter the values manually for each of them and you want it to identify. Like you will have to give each of these values, like a sample patient record. If you want to give also, you can do that. All right. So I'm going to validate it against my existing sample because I'm not having a test data for it. So it is the same data. Yes, so the model has finished. So we will, sorry. Yeah, so you will have to view the applied model, okay? So it has taken the best model with feature selection. It tells you which algorithm, which feature selection, what pre-processing it did, okay? And it is finally giving you the all the metrics that you wanted. Now, if you want to see how well it has made the predictions on your data set, it will also give you the predictions file. So I will show you how the prediction file looks like. Right? So for the sample 0, what are the values? Okay. And it classifies it as high risk. So there is another column it adds on its own, difficult to predict. If you see, nothing was difficult to predict. JADBio is able to predict everything and it is also able to give the class. And is also able to give the probability towards each of the classes. So the first one, it is having a higher 85% towards high risk. So that is why it is putting it in high risk. Okay. So if you take a mid risk, it's 0.969, which is taken as the mid-risk class. Then when you take it as a low risk, the middle one, 0.78. Okay, so it is taken as, so it is high, low, and then middle. So it is able to give you the values as well. So this is very important when you're writing papers, because they will ask you, how do you prove that it is in this class or that class? If you have a new test data, just one sample also, you can apply this model and get your result for that particular sample. That can be written as a paper with a case-based reasoning system or a decision, recommender system. So this system will be able to recommend what is the class for that particular input which you are giving. So that is all the features of this JADBio. And this is what I wanted to say for today's session. And I think I've correctly completed it in 1 hour. So if there's, I just will finish with Vega. Okay. Just that I wanted to show you what is the difference. Auto Vega is there. So whether you have installed or not, let it be. So coming here. So here, once you install it, you will get this Auto Vega here. Okay. So let me open the file. CSV files, I have it in downloads. Maternal health risk data. So yes, I have got all the data sets here. So I just go to AutoVika and I start my, okay, this is also very simple. You just go and start. You don't even have to choose anything. So we will see what AutoVika gives us. All right, then you will know what is the difference between this JADBio and AutoVika. So I complete my presentation here and I hope it was useful to you. If the audience have any question, you may please let me know.
Good morning. Good morning. Can you hear me? Hello.
Yes,
Hello.
sir.
Just a minute, sir. I will stop my sharing now.
Are you able to hear me,
Yes, sir.
madam?
Yes, ma'am. Yes. Ramesh, sir, please wait, sir.
I think many.
Dr. Ramesh, sir, you can ask questions, sir. Any questions?
Yeah. Good morning, madam.
Yes, sir. Good morning. Actually, your
Hello.
voice is
Are you
breaking,
able
sir.
to hear
So
me? I think
Yes, sir. Your voice is breaking.
Voice is breaking. Just a minute.
Is it open? Hello.
Sir, you carry on, sir. You ask me. The problem is I'm not able to get back to the Cisco main page. Just stop sharing. Fine. Yeah. I'm feeling better now. Yeah. Tell me, sir.
Because you nicely talked about auto ML. My question is that for biomedical applications, say for example, you emphasized on cancer, disease, and all. How effectively we can apply auto ML algorithms so that we can predict and detection of.
Yes, sir. We have already applied AutoML in all the data sets. Actually, like you said, I can show you an example here of autism data. Cancers are very big. Let me.
Not only cancer, in any other disease.
Sir, like the data set that I showed you right now itself was a maternal health risk data, right? So any data set you can apply there and it will be able to show you the features. And if you have any new test data which you're getting from hospitals, again, you can load it into JADBio and it will give you the predictions. And it will also tell you what is the value of the predictor. Like I showed you in the file, it will be able to tell on what basis it is telling that it is a high risk or a low risk or a lung cancer or a gastric cancer patient. So it is giving you all the information by itself. So, and JADBio is an authenticated tool in which there are a lot of papers. Okay, already there are many publications. If you take JADBio in very high impact factor journals, it has been considered as an authentic tool. Its results are considered authentic. Just a minute, I can show you the papers as well. You just Google it, it will be available. So that is when I started using JADBio.
Okay.
Yeah.
And at one point of time, you said that auto ML algorithms far superior than deep learning algorithms.
Not only AutoML, I mean even traditional machine learning like decision tree and other things perform much better than deep learning, especially in terms of accuracy, easy to understand, and you actually can see the results. In deep learning, all you can see is the final accuracy, and maybe in image processing, you're able to get the features in object occlusion, segmentation, maybe in those things you get the features. But as far as I'm concerned with medical text data, deep learning accuracy is very, very reasonable compared to traditional learning algorithms. And AutoML has not yet been totally applied on all deep learning. So deep learning is just increasing the number of hidden layers, right? You keep increasing the hidden layers so that you do more processing and you try to get a better accuracy, or you increase the number of iterations. From 100, you make it 500, so it keeps the training again and again and again, and it gives you a better accuracy. What I'm saying is doing all those efforts in deep learning. See, to run 500 iterations on 1 GB data file, how long it is going to take? Why you have to struggle so much to get that accuracy when you can get maybe 1% less accuracy with machine learning? No, that is my point. That's all. So I'm not saying that deep learning is totally a waste, not at all. It does work very well with images, but I think the efforts and the time we take to understand. Now, if I ask somebody who's a deep learning expert, what does the Adam function do on this data? Most of them will think twice.
You mean in less effort, we get a good results in
conventional
ML.
algorithms, yes.
That's what you said.
Not less effort in the sense, even the, what do you say, the amount of time, sir, deep learning takes a long time to run and it makes my system very slow.
Yeah.
Whereas the JADBio didn't affect my system because I'm using it on the browser and it has CPU cores of its own. So I'm able to do all my work very well. So at the end of the day, that is what we are doing, like trade-offs. That is what computer people are meant to do, which is the best. Yeah.
Which is the best. Okay. Thank you, madam. Thanks a lot.
Yes. Now, just a minute, I would like to share my screen again just to show you this Auto Vega, okay? How slow it is, so that you will just... Now, see, I gave that small data set and it is still running, okay? And the results also will not be like it is in JADBio. See, for this small data set, it is running for such a long time. Then on big data sets, Auto Vega takes a long time. And the results will not be as good as it was in JADBio. You cannot choose anything here. It will just give, this is the result with all this accuracy, kappa statistics, and so on. So there are a lot of AutoML tools, but trying to figure out which is the best one, that's up to us. So everything gives some result, but when we have to analyze, we need the ones that give the best results to us. Yeah.
Good. Thanks, madam. You made a good point. Thank you.
Thank you, sir.
From audience side. Sabida, you can conclude.
Participants, please make sure to fill the feedback form sent. And tomorrow's session is on Prakash by Mr. Shankar, Enterprise Architect at Aquatech. And timing for the session is from 7 to 8 p.m. Please make sure to attend the session. I would like to conclude the session with a word of thanks. We're delighted to have Dr. Shobhana Grace-Chadha with us today and giving us this informative session. We also want to convey our thankfulness for accepting our invitation and providing supporting knowledge and